You know when something just isn't quite right? So I'm a massive inheritance machining fan, and I think if you have watched as well, you will know that Brandon has his box of shame, and I didn't want to directly copy him, but I think there should be a very British version, so that's what I'm making right here. Behold the chest of disappointment. That's better. That's been niggling at me all week. So I realized I just kind of jumped into it last week. I didn't actually explain what I was doing. I told you what I was going to make, and then I just started making it. And I feel like it would be good just to quickly run you through what I did before I move on to the next step, because yeah, I think it'd be helpful. Yeah, I was turning the pinions, but I only did the front half. So let me do a little diagram and explain it to you. Right, so this is my amazing drawing of a pinion. This surface is where the leaves are. This is where the wheel would rivet to. This is a little step between the rivet and the pivot, and then that's the pivot. Then on the other side, this is kind of into another intermediate step, and then the pivot. And yeah, so that's the general construction of a pinion. What I did last week was I turned all of this and this long surface here, but I didn't turn all this. I left all of this long on a bar. So then when it comes to cutting the leaves, which is all on this surface and has a lot of cutting forces involved, especially in steel, yeah, you want as much material here in the body to minimize deflection when you're cutting the leaves along this surface. So yeah, that's what I did on all the pinions. I did all of this end and this long surface ready to be cut. And then once all the leaves are cut, you come in and you can back turn all of this, and then it should all then be concentric to each other as well. It's a nice way of doing it. In theory, I don't think you would ever want to attempt turning it all, like turn all that, back turn, and then cutting leaves. You're always going to get some deflection there. Even with this method, you'll probably get some form of deflection. It's just always present in some capacity, but yeah, this is what I've done on all of them. It varied in sizes. As you saw, the center pinion was huge compared to the escape pinion or the minute pinion. So yeah, that's where we're at. The next thing I need to do is I need to turn just a bar, which will be literally just one long diameter, and then that diameter here, so from there to there, that I'm going to make the root diameter of the leaves, and I'm going to make that as accurately as possible, hopefully to within 1 to 3 microns is the aim. And then I can use that to set the depth of my tooth cutter when I come to milling the teeth. So yeah, so if that's the root diameter, all you have to do is bring the spinning wheel, which is like, if that's a side view of the leaf cutter, that goes like this along the surface to cut the leaves. All I would do is bring it down to touch onto that surface very lightly, or make it touch it and then just bring it up a micron or two. And then that means when you cut these leaves, it doesn't matter how much material you've left over the diameter, because on all of these here, I've left those about 0.03 of a millimeter oversized, but here is where it will eliminate that 0.03 of a millimeter and bring the outside diameter of the leaves to the correct diameter. And then we need to make another bar of this, which is just a one-turn surface. And we want to make it about this diameter, but ideally we would make it the finished outside diameter of the leaves. And then we can use that to center our cutter. So we'll put the first one in, set the depth, take it out, put in the next one. We can then center it without wasting a pinion. And then once it's all centered and depth set, we just load in the pinion and we're good to go. So that's the plan today. We'll get going, and this just needs to be in brass, so it should hopefully be a quick process. I've just scrapped that center pinion because it was niggling at me all week. I don't think that center drilling was as good as it should have been. A friend of mine's come up with a technique that might work to integrate maybe drilling that bore in the CNC. So, but yeah, I'm not going to do that today. I'm going to just continue on with the pinions that I've done and try and get those through to finish for you guys. Because then when they're done, we'll be able to move on to some cool CNC stuff and make a main plate and a barrel bridge. So I didn't think it'd be worth me showing you me making all of these, but yeah, here's the end result. I had to make a few of them all, but I got it done in about 45 minutes, so it was pretty quick as lathe operations go. I'm pretty proud of these lengths of swath. I think this one here breaks my record of longest one ever. Right, so this incredible dividing attachment is created by the wonderful Luc Monet, incredible watchmaker. I always refer to him as your favorite watchmaker's favorite watchmaker because he's just incredible. And yeah, you can see there's quite a lot of holes here. This has every division. Let's have a look at the sheet. It has every division from 1 to 360, but obviously not every single one, but it's got a bunch of variations. So the way that this works is we've got this template that goes on top of the dividing attachment. And this shows you which circle you need to be on. So top is 360, bottom 174. So that's the amount of holes that's in that circle. So that just goes, let me try and position this well. So if you see here, there's one dot that's on the inside of this ring. Sorry, I'm really struggling to position this. And then that shows you, you can see they're all in line. So that is the first division of all of these circles. So that's where you always operate off of when you're marking out your divisions. So the way that it works is we put this on here, and we line it up with that hole, like so. So then we can see, like I said, what circle that we're in. We are going to need to do 8 divisions and 10 divisions. So if we go onto our sheet, 8 there, so we can be in circle number 360, and then that means we need to make a mark every 45 holes, and that will create our 8 divisions. And with 10, we could be in 360 and then do 36 holes. But because I don't want 2 markings in the same circle, because that would get too confusing, it also offers an alternative here. So for number 10, I will do, circle 240 with 24 hole offsets. So I'm going to get cracking and mark all of those out and then show you what it looks like when we're done. That one's going to be here. So that's 8 divisions. And we end up at the start again. So I'm going to mark out the 10 divisions and then we will be good to go. Right, so there we go. We've got 8 divisions on the outside and then 10 on the inner ring. Which means we are good to go to cut some pinion leaves. What? So that's put a spanner in the works. This is the arm for the location pin for the dividing attachment. This is meant to move through here completely, and it's stopping just as it goes in, on that end at least. That end it goes in, but the tapered bit comes through. And looking at it, it looks like the end of this has been munched in some way. So it's kind of closed up the end hole. So that's kind of put a halt on things. You need the dividing attachment to be able to cut the leaves. So I think I'm going to, for the sake of actually being able to get stuff done on the weekend, I'm going to just save sorting that out for the upcoming week and resume this again. But it's not all bad news because it means we get to move on to this, which I'm really excited about because I've done the cam for the main plate and I've made the fixture and it's really cool. So yeah, I think we just pivot. It doesn't really matter the order we make these things in. I wanted to make the main plate first anyway, but the material wasn't here, so I got cracking with the pinions. So yeah, sorry to halt things again. I think I did this exact same thing when I was doing pinions for my wristwatch. Something got in the way and I stopped. So we still haven't seen cutting leaves or teeth yet, but we will eventually. We just need to sharpen up and yeah, make sure these things don't happen. But yeah, they do.
2,000 years later.
Shake it up. Oh my god. You piece of Jesus Christ. I don't know what came over me there. That was genuinely an hour of sawing through 76 millimeters of brass. So yeah, that sucked. I have tried to face it as much as I can, but you can see saw marks look horrendous. But I think they're good enough to be able to put in the CNC now to clean up that face, because both sides need truing to each other. Well, that side needs truing to that side. I faced that one off nicely before I parted it off. So, well, I didn't part it off. I attempted to part it off and then I had to f***ing saw it.
Can you tell I'm mad?
So yeah, I have 3 printed some soft jaws. I printed them solid. 3D printing, you typically have like a sparse infill of like 15%. I printed this 100%, so it's just solid plastic. So I'm hoping it's able to clamp it correctly. And with enough force that this doesn't go flying when I machine it. But I'm only going to be lightly facing it, so it should be okay. Yeah, let's get that installed and have a look at what the first cuts look like for the pocket watch. It's hard to know how much to tighten these because the plastic compresses. but it shouldn't compress too much. Torque wrench would be good right about now, but alas, they look level to me. Feels solid enough for what I need it to do, I think. It has to be. So here I've just measured the tool and I'm about to adjust the tool offset. So I can use the tool offsets to fine tune the diameter of, or fine tune what the machine thinks the diameter of the tool is, and the length. Now I'm calling up the probe. And then bringing the probe into position, bringing it about 10 millimeters over the part. And then I'm going to run the probe cycle, which is just probing off on the top, and that's going to tell me where the 0 point is, and that's where the program will run off of. You can simulate what is going to happen. So it's going to go yep, G54, which is where we need it to be. T1, right, cycle start. This is where things get very hard to see. Seems to be holding up okay. Right, so I took that down another 0.5 millimeter, and as you can see, it's looking stunning. It's odd that this pattern that you see, it's perfectly smooth. There's no 3D texture to it at all. Like if you could feel it right now, it's pan flat. There's still a slight, you can see here, a slight showing of the saw marks, but that's perfectly fine for what we need. It's not raised a burr or anything on this surface, and yeah, we'll be able to go along with that. But yeah, look at that pattern, it's gorgeous. So yeah, I think I'm actually now, because feeling how lovely that side feels, the side I face now actually feels rough in comparison, so I think I might flip it over, quickly face off this side, and then check the parallelity before we move on. That is the beauty of CNC right there. We have two stunning faces, and yeah, that is the perfect starting point for what we need to do with our main plate and our barrel bridges. We need to start with good stock. We need to then put some screw holes and counter bores in there. We need to put, once we've got those in, we can put it on a jig. Let me show you the jig. So here is the jig that I made. It's a two-sided barquette jig. You can see the amazing surface finish on here again. Again, this is perfectly smooth. Like, you cannot feel any of these ridges. It's a gorgeous finish. And it's got these two location pins, location pin bores in. These location pins are precisely ground to about 3 millimeters. So that's, we'll put two bores in that piece of stock I just showed you. And that will allow us to locate on there. Then we can flip the part and machine on both sides. And we can kind of basically do that infinitely and it locate back hyper accurately. So we can work on both sides as much as we need. So yeah, this is the wonders of CNC. We're able to create jigs that we need really, really quickly with the accuracy that we need. We can prepare the stock before we even start proper machining. So yeah, there's a lot of amazing things that we can do here, and it's really exciting. Right, so I've checked it with both the micrometer and the indicator. Both of these are accurate to about a micron. And yeah, we're seeing it's out of parallelity much more than I would have hoped for. It must just be down to the plastic soft jaws because the machine is accurate. So yeah, it's about 90 microns out of parallelity. There's kind of looks like majority of the disc, like 3/4 of the way around, or halfway round, there's like within 15 microns, and then it jumps up massively on another. So I don't know if it just wasn't sat properly in the soft jaws, or once you tighten the soft jaws, they kind of bulge a bit because they're only plastic, they're not metal. So yeah, I think the only thing that we can do is, which I wanted to avoid, is glue it down to a glue jig. So then we truly are locked in and referenced off of one of the faces. And then we'll do the operation that we did in the soft jaw, it's just on the glue jig. And yeah, that should bring us to the parallelity that we need to move forward. And then I'll just call it a day there for the video because yeah, now this is going across 2 days and it's Sunday, and then I can't do anything Monday to Friday. So yeah, I'll call it there. Right, so here's the glue jig. You can see the outline of wheels. That's because I was making balance wheels the other day at work. But should be fine because we've got such a large surface area on the material that the kind of interruptions in where it's glued down, it shouldn't be an issue here. I'm only skimming the top. It just needs a solid surface to go against. So the work holding that we use to do the majority of components is this System 3R chuck. It's called a 0-point system. So let me demonstrate. So you can just literally undo this, and then you can take your fixtures in and out. So this one is kind of like a mini version of the one I showed you earlier on. This is the two-sided barquette jig, so we can do two-sided components. So on here I would do like the main plate, all of the bridges that have features on two sides. So yeah, and then because of the accuracy of this, these faces here, they all reference against the underside of the pallet, and that means that you can take things in and out and put them back within a couple of microns, which is very nice. You don't have to worry about reprobing the X and Y of your jigs, but obviously you always need to probe the Z. So all you do is locate it and then tighten it up. And that's solid, and that's good to go. So we are going to lather our material up with this Loctite 438. So I'm really going to make sure that I lather this up. You want it to the point it's spewing out the sides, because then you're absolutely sure that there's good contact all underneath. So there we go. And then we are going to really smother it and apply pressure, because this glues when there's an absence of oxygen, as far as I'm aware. So you don't have to rush to get it down, but as soon as you get it down, you then need to be sure of where you're putting it and start applying the pressure, because it will start hardening pretty quickly. So here we're not going to be able to probe the boss of this material, because the height of it is smaller than the radius of the probe, so we're not going to be able to get it down to contact the sides without touching the actual glue jig. So considering it's not an accurate, it doesn't need to be accurate because all we're doing is facing. What I do in this kind of situation is I roughly get the center, and I will then, because I know what the diameter of this, it is 76.2. So half of 76.2 is what, 38.1? So I just position the X. So there's 38, around there. Then I'll do the same in the Y. There we go. So that there, I'm going to save as my center. And then we can probe the top of the material, and then we can start machining. So bring the probe into position. And we do it about 10 millimeters over the stock. Doesn't have to be that accurate as long as it's less than 10 millimeters. And then we're going to probe this top surface. There we go. We are good to go. When I run a program for the first time, I always like to lower the feed rate so you see it coming down really slowly so I can catch it if there's going to be a crash. But as soon as it's going and there's no crash, I set it back to 100% feed rate and it's good to go. There we go, it's fine. Right, I'm really happy with how that went, and I should have really just done that in the first place rather than try and deal with the soft jaws. But I was just trying to save time because this is going to probably take over 24 hours to unstick itself from here when it's soaking in the acetone. So yeah, I was hoping to get more done this weekend, but yeah, it's fine. So the final thing I was doing there, I just probed different areas of the surface to see kind of what readings I was getting, and it was all within 1 micron of each other, and that's the flatness of this surface based on the machine, and the fact that this surface was made flat to the machine, as long as we applied enough pressure and this was glued flat to this surface here, that should be flat to the other side of the material. So yeah, we won't know for sure until we get it off the fixture, but yeah, all we can assume is that was at least better than the 90 micron kind of region we were in before. So yeah, thank you guys for watching this episode. I feel like it was a bit of a weird one, flipping between different things, but hopefully, regardless of that, you learned some stuff. Yeah, this is the first kind of dipping our toes into the CNC with this project, which is exciting, but it's only going to get more exciting from here. We just machined a flat disc, and yeah, next we're going to machine things like the main plate. We're going to machine all these different features, and yeah, we're going to incorporate sandblasting in the middle of doing the machining, which is, yeah, I'll show off the jig because that's the beauty of the jig. We can take things on and off and do things in the middle of processes, which is exciting. So yeah, I don't know if there will be an episode next weekend. If there is, it will only be a short one, and it will most likely be cutting the leaves on those pinions. That's if we get that kind of pivot arm sorted this week. But yeah, next weekend I've got a few live things going on, so nothing I can do about that, unfortunately. But yeah, there might be a short 10-minute video potentially, but don't hold your breath. Thank you for watching, and I'll see you next time.